Again, thank you everyone so much for coming. Sorry about the technical difficulties we've been experiencing. So my name is Rachel Stevenson. I am a graduate student here at the University of Colorado, Denver in the Applied Geography and Geospatial Masters of Arts program. And so a little bit about me, aside from the fact that I'm a graduate student, I am also the co-founder of MapTime Boulder and MapTime Mile High. I run both of those groups, which focus on allowing the community at large and students to come and learn about open source software and applications that have to do with geospatial and geography. So I do a lot of community and citizen science work. And so I'm really happy and excited to be presenting Introduction to Citizen Science today. So I have some interest, obviously, in OpenStreetmap as well as interactive web mapping and natural hazards and emergency management, and how we can use citizen science to better our understanding of how people are impacted by natural disasters, and how emergency managers can best serve communities based on real-time citizen science data about events that are unfolding. So yeah. So this entire session is an introduction to citizen science. And so when I originally decided to create this topic, it was out of a need to stop just jumping into OpenStreetmap and to take a step back. Oftentimes when I run MapTime Boulder or MapTime Mile High, we just do a basic introduction to OpenStreetmap. We talk about what it is, but we don't talk about the bigger picture, and that is citizen science. Citizen science is citizens, the public, people like yourselves who are crowdsourcing data, who are going out into their communities using their own understanding of the world and telling others about it through applications, databases, various interactive websites such as OpenStreetmap, as well as the National Map Corps. So we use citizen science all the time. It's not just a strictly geography or geospatial thing. We use citizen science from Wikipedia to iCoast, which I'll explain that in a few minutes, to, again, OpenStreetmap. It's used in a variety of science fields and even non-science fields, so like Wikipedia. So SciStarter, which is a nonprofit, has this to say about citizen science. Citizen science is the public involvement in inquiry and discovery of new scientific knowledge. A citizen science project can involve one person or millions of people collaborating towards a common goal. Citizen science allows for people like yourselves who have personal, intimate knowledge to bring that knowledge, that personal firsthand knowledge, to research that's being conducted. OpenStreetmap is great for this because people who live in a geographic area can map their geographic area and be the owners of that data and say, yes, this data is correct because I live here. I am really well versed and I can identify all of this geographic area because I know it personally. So there are other terms for citizen science. Sometimes it's called crowdsourced data. Amateur science is a term that's often used. Volunteer science, citizen collected data. All of these terms often refer to citizen science. So a couple of examples of what citizen science is. I've already mentioned OpenStreetmap. There is HOT OSM, which stands for Humanitarian OpenStreetmap Team. They are a nonprofit group that kind of merged out of OpenStreetmap that maps disaster areas. So right now they are currently mapping the earthquakes and those impacts of that earthquake in Japan that currently recently happened. There's Mapillary, which is a mobile application that allows users to go around and take street level views, street views of the area that they live in, kind of like Street View and Google Maps, but for OpenStreetmap. Geotag X is one that I've just come across recently. And so Geotag X allows for volunteers to look at photos of before and after a disaster and analyze how much damage has been done because of a disaster. The National Map Corps is very personal to me because I work for the United States Geological Survey. They are the group who runs the National Map Corps. And they, the National Map Corps is very similar to OpenStreetmap in the sense that you go in and you use a web-based interactive web map to plot structures that are in the public domain. So things such as hospitals or post offices. There's iCoast, which is another United States Geological Survey citizen science initiative. And they also do a lot of work similar to Geotag X. And so they look at photos before and after of the coastline in the United States, looking at before and after disasters along the coast. This was really, really prominent and important during Sandy, Hurricane Sandy, because Hurricane Sandy literally changed the look of the coast after that hurricane had come through. Missing Maps is the last one that is specific to geography. And Missing Maps is a nonprofit that asks other geography, other geospatial communities to say, how can we look at maps, what maps are missing that people who are on the ground doing natural disaster work, what maps are missing that they need? And so Missing Maps puts out a call to the community and says, we're missing these maps of these geographic areas in this disaster. And so we would like it if the community at large could create these maps for us so that we have viable data. So why is citizen science important? Why do we care, essentially? Citizen science is really important for a number of reasons. Firstly, it makes science more accessible. It makes science more accessible to minority groups. It removes it from being strictly an academic space and topic. It makes it more accessible to large communities. Citizen science also fills a void by letting people bring their own personal knowledge, as well as makes it cheaper for us to collect data and to get a lot more data for free, essentially, because we're asking volunteers, we're asking just people who are interested in the topic at hand to go out into the community and document whatever it is that we have asked them to document, whether that is tracing structures like an OpenStreetmap, or just plotting public structures like post offices or hospitals. So often the data that is collected, is in the public domain, and so it makes it easy for people doing other projects, other scientists, other data scientists to take that data and use it for different purposes. Twitter is one of these examples. I have a friend at CU Boulder who is looking at Twitter data that is geo-referenced and looking at how people during Hurricane Sandy interacted with Twitter. What did they have to say about what was happening on the ground? Twitter is great because it gives people a way to discuss what is happening right then and there and how it is impacting them. And so Twitter wasn't originally mentioned because it is not strongly focused on geographic issues or topics, but Twitter is a great resource for citizen science collection and open data because it's all tagged, right? So a lot of people use a hashtag like hashtag NYDemDebate. That allows scientists to go in, if they know the hashtag, and get a slew of tweets with that hashtag that's associated with that. So how can we use this data? So we have all of this data that is collected by volunteers all across the country, and sometimes not even in this country, right? Nobody needs to be in this country in order to collect data for a particular purpose. They can be in a series of different countries. Like hot OSM is often not in the United States. It's often data that is collected for other countries that have been directly impacted by a disaster. So how do we use this data? This data is often used and collected for a particular project at mine at the start. And so I have a couple of examples here that you can see on the slides. USGS uses their data to add to their topographical maps. Missing Maps uses their data to provide maps to various nonprofits seeking information about the area that is affected and impacted by a disaster. So they give that data over to governments for their use to make accurate maps of the disaster. Hot OSM also uses this data and they work with local communities to provide, again, accurate maps. So both Missing Maps and Hot do similar type of work. It should be noted that there is a wide range of opportunities for citizen science or crowdsourced data. OpenStreetmap makes their data easily accessible, and people have used it to build on other mapping applications that they've needed. And so a lot of this data is easily accessible to just the general public, which makes it a great resource for various other projects. So there are some challenges with citizen science. It is not perfect by any means. The Scientific American discussed the challenges of citizen science data, and a lot of that kind of mirrored traditional science and traditional research methods. Data management was a big piece of it, right? How do we verify that the data that is being collected is correct and accurate? Data quality. Is the data that's being collected, is it right? Like, is it good? Are we managing it in such a way that it's readable and accessible to us and to the public at large? And then there's a question of bias in data collection. So if you bring all of this personal knowledge, are you also bringing a bias into the data that you are collecting as a citizen? Right, so the biggest question that's often asked is how is this data verified? How is it vouched for? What structures exist to check and ensure that this data is correct? I can tell you from personal experience with my work at the United States Geological Survey that there are a series of steps in place to have not only citizen scientists verify the data by incorporating additional levels. So if everybody starts off, for example, in the National Map Corps, you start off as a standard editor. After about 25 points, you get pushed up to peer review editor. You peer review other people's points to ensure that they are correct. So you look at their location, you look at satellite imagery to ensure that the point that is plotted on this map is in the correct location and is on top of an actual building. As well, there are two other advanced editors. So there is an advanced editor and then a major editor, and both of these editors are looking at capitalization, looking at geocoding your points to ensure that they're correct. And then finally, we have staff at the United States Geological Survey who overlook all of these points to, again, ensure that they're accurate. And so one point can go through all of these different steps to ensure accuracy. So if citizen science interests you and you want to get involved with citizen science, there are lots of communities, both here in Colorado and throughout the entire country, that do a lot of work with citizen science. So I've already mentioned MapTime Mile High and MapTime Boulder, both of which meet at their respective University of Colorado campuses. Mile High obviously meets at the University of Colorado Denver, and MapTime Boulder meets at the University of Colorado Boulder. As well, OpenStreetmap often hosts various citizen science workshops where they will introduce you to OpenStreetmap, Mapillary, and via Light that I've mentioned before. If you are not from Colorado and you are watching this video in another state, you can go to maptime.io and see a list of chapters that are in your area. As well, meetup.com often has a series of meetups where people can do a lot of citizen science and a lot of crowdsourcing data. You can also do this from the very own comfort of your home. If you're doing it for mapping purposes, that's often called armchair mapping. So if you wanted to, you could very well do it from your own home. But oftentimes there are things called mapathons, which allow for lots of people to get together, collaborate, discuss, and work on citizen science initiatives. So there is a Citizen Science Association, and they define themselves as an organization that aims to bring together the expertise of diverse practitioners working in the field in order to share the breadth of resources and best practices across different citizen science project types. If I haven't mentioned it already, there are hundreds of citizen science projects, not just geographic specific, but things like Did You Feel It, which is a United States Geological Survey citizen science project that asks citizens to give real-time feedback about earthquakes if they've experienced one. So that's just another example of other types of citizen science initiatives. And there are, like I said before, there are hundreds of them. So this is just a list of all of the other resources specific to this presentation. Things like Geotag, X, as well as Mapillary, the National Map Corps. So if you're interested in engaging with those citizen science applications or projects, here are some links and a little bit about each of those programs and initiatives. So that is it. Thank you so much for checking in. If you have any questions, comments, I will take them. Dr. Marina.
Can you demo some of these applications because some people might not be acquainted with them?
Sure. So this is OpenStreetmap, and this is the front page when you come to it. So on the side, you have obviously your zoom in and your zoom out. You have your location. So if you enable your location or GPS device on your computer, you can get located in the area that you're currently at. There are layers. These layers are not like your typical GIS layers. When OpenStreetmap talks about layers, they are discussing base maps. So you can choose various types of base maps depending on your preference. This is a map key that tells you all of the roads, all of the different structure types, kind of just a legend that tells you what this particular map will show you, and that legend will change based on the base map that you're using. You can share it, you can add notes to a map. You can add notes to a map without having to log in. So if you see something that is incorrect, but you don't want to change it yourself, you can make a note of it and somebody else will come in and later check it for you. And then this is a zoom into query feature, so features that are questionable. So if you come over here and you click Start Mapping, you'll be brought to the editor. It should be mentioned that there are 3 types of editors, or I think there's, okay, hold on. So there are 3 types of editors. There's Potlatch, which is also a web-based browser that you can use to edit. There is ID Editor, which is this editor here. And there is Java Editor, which you can download and edit offline. The only problem with editing offline is that your edits will not be done in real time. So once you are done editing for that session, you'll need to upload your edits into OpenStreetmap. Let's see. Okay, so this is Aurora campus. This is where we are right now. So as you can see, a lot of points have already been plotted. This is the science building. This is the North Classroom. So this is where we are right now. So as you can see, the cafe has been plotted. But what has not been plotted, which I'm going to plot for you now, is the Fast Lab, where we are right now. So I'm going to edit with ID. So as you can see these other editors, ID, Potlatch, and Java. And there's a tutorial that comes up automatically, as you can see. And so if that is something that you want to go through, feel free. It's really helpful and useful and gives you a lot of great resources to use throughout your mapping. So I'm going to go ahead and plot I'm going to plot the Fast Lab. So there's not an address here. So a lot of times with OpenStreetmap, you can, if it seems like there has been a lot that has been plotted, what's really helpful is accurate attribute data. And so if I wanted to, I could put in that there are 5 levels. Does anybody know the address? No? Okay. I know we are on Spear. We know that we're in Colorado. I don't know what the zip code is. And so you can add a lot of various information. You can add the website, if there was a website specific to this building. You could add a Wikipedia article. You could add if there was wheelchair access. You could add a lot of information pertaining to just this one building. So if you wanted to plot a point, you would
That address is like 1100. Oh, sorry.
Okay.
The rare library.
Okay. Okay. Great. So if I wanted to come in here and obviously plot the Fast Lab, I would go up here to the point and drag, and I would identify it. Identifying this as. For now, we're just going to identify it as a point. OpenStreetmap has a very long list of identifiable structures. You can use OSM Wiki to look at all of those structures, but for now, because this entire building has already been plotted, I'm just going to use a point to identify this as the Fast Lab. Can somebody tell me what the F stands for? Because I know the FAST is an acronym. Yes?
Facility for Advanced Spatial Technology. For advanced.
What was the T?
Technology.
Technology, okay. So if I hit save, all of a sudden when you scroll over sometimes, So OpenStreetMap does all of its edits when you use ID or Potlatch in real time, as opposed to JavaScript or just Java. Java OpenStreetMap editor, which you have to upload your edits at a later time.
Please mention for the benefit of the recording that there are some resources out there, and also that you will be trying to prepare some tutorials for these.
Right, yeah. So there are lots of resources available for OpenStreetMap. Like I mentioned before, there are meetup groups like MapTime Boulder, MapTime Mile High that often and frequently do introduction to OSM. I will be doing various tutorials on OpenStreetMap over the summer and hopefully into the fall. There will also be another workshop just like this where I will give another introduction to OpenStreetMap. Also, there is a large online community of OpenStreetMap users. And so places like Stack Exchange or the already built into OpenStreetMap Wiki has a lot of resources and a lot of information. So there is no lack of information pertaining to OpenStreetMap. And OpenStreetMap is just one of the many geographic applications for citizen science. Brian.
How long does it take for your additional input to go on the site?
So I think, sure. So Brian asked, how long does it take for an edit to go live on the OpenStreetMap map that you saw that was the front page of openstreetmap.org? I think the edits are like instantaneous right there. If there is an incorrect point, like if the FAST lab doesn't exist, obviously we know that it does, but if for some strange reason it no longer exists at a later time, other advanced editors will come in and flag this point for removal. But all points are instantaneously updated to the main map once you open openstreetmap.org. Now this does cause a bit of a problem, right? Because I could go in and plot a road, and Brian, you could go in and plot a road, and if they were even a little bit off, say I added attribute data and say you didn't add attribute data, both of our lines would be in the OpenStreetMap database. So there is a lot of repetition with points and volunteers. Yes?
So bring my second question. So you mentioned the peer review process when talking about like the projects and stuff, just like in general citizen science. So if people becoming more aware of the citizen science, it seems like it opens doors and like potentially flood different projects with an overwhelming amount of data. How do you anticipate these organizations and agencies compensate for the different margins of error, just other erroneous data?
Sure. So the question was, with citizen science becoming more popular and more well-known, and there being an influx of volunteers who want to give back, who want to get involved with these projects, how do we compensate for a lot of those repetitions and margin of error? That's some of it. Okay. So I wish, right now we do not have that problem. The volunteers that we do have, I'll use the National Map Corps as an example. We have more projects than we have volunteers for currently. If it ever does come to a point where we do have a lot of volunteers who want to partake, we'll just be able to expand what we do with that map. So in regards to repetition and margin of error, these standards and these structures need to be in place by every citizen science project, right? Where people are vetting that knowledge, where people are saying, this is correct, that's incorrect. And it takes a lot of volunteer hours to do that. OpenStreetMap also offers what's called map roulette, where it identifies a point as being incorrect, and then volunteers go and correct that. So that's another avenue for people to get involved. kind of just expanding those opportunities. Okay, great.
Demo geotag.
Demonstrate what?
The geotag X.
Geotag X, yes. So this is the website for Geotag X. Within Geotag X, there are a lot of projects, kind of like Hot OSM, which provides a series of tasks that organization would like to focus on. Geotag X is focusing on, this is just a small section of what they're focusing on. Ebola, emergency shelter assessment, flooding, the Somali drought, and whatever your interests are within emergency management and disaster mapping, you can find a project in Geotag X that will reflect that will need support for it. So I haven't created an account yet with Geotag X, because I just found this out a few weeks ago. Okay, so I am signed in, and so I'm going to do Ebola response. I'm going to do Sierra Leone. And so obviously this also gives you a tour. This is not where I want to be. That's where I want to be. All right. So what you'll do is you'll look at this photo and you'll plot a point for it within the area. Not really sure. So I need more time to work with Geotag X before I really give a presentation on it. But it looks like a great website and a great project, and has lots of opportunities if you're interested in natural disaster mapping. But give me a little bit of time before I dive into Geotag X. Let me actually get familiar with it first.
So Geotag X concentrates mostly emergency response and test.
Right, yep. Hot is a little bit easier. It uses the OpenStreetmap application and the ID editor to have people just continuously plot what they've been plotting in OSM. So you're plotting structures, you're plotting roads, you're just providing an understanding of that geographic area, so that Hot can say, okay, this is a road here, this is a bridge, this structure here over here is or was a school. Believe it or not, a lot of countries don't have accurate maps of their own geographic boundaries, especially for countries who are at civil war or who have been directly affected by a natural disaster. A lot of their landscape oftentimes changes. And so because of that, there's a constant need for people to go in and map during a natural disaster so that you have the most up-to-date and accurate information. And that's where citizen science plays a huge role. So, yeah.
Would you mind showing again the list of the different points that we have mapping diary and those just to summarize so that people can look
Sure.
at their own each of them?
Sure. So SciStarter is a nonprofit that also works with citizen science projects to provide some structure. They help to vet these projects and the data that comes with it. Scientific American is a magazine as well as obviously as a website. And they provide a database. I think they have about 12 pages on their website of citizen science projects that just range from, obviously mapping and GeotagX, which is where I found, Scientific American was where I found GeotagX, to earthquakes, to tornadoes, and various other interesting scientific or crowdsourced applications. We've already mentioned GeotagX and OpenStreetmap, but these are the links for those if you want to be involved. The National Map Corps has already been mentioned, and here's the link for that. And then Mapillary is a mobile application. You cannot do it on your browser. However, you can view all of the photos that were taken and view them on a big computer, like a laptop or a desktop computer. So that is all. Thank you so much for spending your evening with me. I appreciate that. I am super sorry about the technical difficulties experienced earlier, but I hope you have found that this workshop has been informative and helpful.